Hello everyone, I am Bharanivaran. Today we want to see about what is a PLC and what is latching. The PLC is an advanced version of an relay automation. First of all, relay is what can do and communicate with another pin. We can do an NO or NC, which will be a very often another to output. Same logic. PLC can withstand a whole of 24-hour bypassing another feature module where we can do an more set of programming with the PLC. First of all, what is PLC is a programming logic controller with an this will be a architecture of an PLC where having a central CPU processing unit where controlled by input and output modules are separated by a security system or a protective system where withstand the capacity of an voltage from the industrials are very high. So the 5 volt only where can be CPU or a process will be done. Another input and output modules are 24 volt or maybe a 24 to 30 volt to 24. But the industrial process only PLC were doing. This was for the PLC were integrated with the conventional better for an industry based thing, not for an home based or anything. First, want to have an idea about latching. Latching, suppose we have to use an push button only in the industry. The push button we have to the push button we only use about to start in one click and stop in one click. We don't have to push. When the push, then we have an output of an light will be on, and when we get off the guy remove the hand, then we'll off it. No, it's not like that work. But the first of all, latching will be a continuous output with the stop output. So we want into the Siemens we are ready to make an latching circuit. First we want to how the NO and NCs are working. NO means a naturally, normally or open, or naturally or open. It will be like I will explain as brief of it. First of all, a NO will be like that. This NO will be like this. This is NO, and suppose it will be like this is NC. What NO and NCs will do? If you are having an LED, if you are having an LED with supply positive negative with switch to the ground. NO means it will be off normally. When you on, when you on, it will be pass electricity. Then it will on. Then it will on. When that's the normal application where direct into PLC, where it is will be main conditions. First of all, want to percentage M1 start loop. I want to start. I already declared the values. It was an NO. When the press, it will be a NC, and then the output will give. Again will be stop. It wasn't why we getting stop like that. It was an close. When here will be a stop, it will open means it also will be start. If it will on, then the current will come, then it stops it. Then it will on. Then if it is also on, that will be a positive conditions. So that's why we are putting a stop in these conditions. Whenever we putting a start button on, then will be start will on. Whenever we put on the stop, then will be it cuts the start. Also we want to declare an output will be a latch, memory latch, output latch. Also latch means it was a continuous output. Want to give a continuous output with the condition. of output latch. Basically, I will simulate how it will be work also. When it will be done, we can do a compilation, we save the projects, we can do simulation. It will be take, I think it was some roughly 5 simulation software. I do it with an simulation only. It will be the procedure of an hardware that also video will become. Will be loading into the program for the PLC. Yeah, it's done. If we put an this like such if you want to clearly see, it will a green light which is blinking. It is a power coming. It was an on condition one. If we put an start, it will be on. Then it gives an output. I want to modify into one. Then it also on the condition will be on. It is on condition. If we want to stop, we don't directly stop it. It will be a fail condition. So because the start will already on with the latch, we want to switch the stop, want to stop the whole process. That is also natural global logic. If you stop this, it will be stopped. Give us the latch output latch. Oh, okay. That will be a clearable thing, I think. Thank you.